Machine learning has a lot of potential in healthcare, but why machine learning and especially deep learning techniques aren't broadly adopted within the healthcare system yet? What are the gaps between academic research and production level code in deep learning and healthcare? How can we mitigate this production level gap in deep learning and healthcare? And what are some of the tools and techniques we can deploy? Welcome everyone. I hope you are enjoying your COVID time in lockdowns, but today we are going to discuss deep learning in healthcare and its practical limitations, and we are going to answer these and other questions. I am honored to have the speaker today, Karthik Bhaskar. He's a machine learning researcher at Vector Institute. My name is Jiri, and I am a stream owner of machine learning economics, but this is a stream of machine learning in healthcare. Also, let me briefly introduce ACE. ACE, also called Aggregate Intellect Socratic Circles, is a community of machine learning practitioners and researchers who gather around 3 topics in AI, and that's research, engineering, and products. We host 3 live sessions like this 3 to 5 times a week, and produce premium content in various subject areas. To see more, visit ai.science and log in to access slides from this and other sessions and many more. And now I'm going to pass my words to Karthik.
Thank you, Jiri, for the kind introduction, and thanks for inviting me for this presentation. Today's topic is about deep learning in healthcare and its practical limitations. Before I start my presentation, I would like to say that my first part of the presentation is about like high-level deep learning and history of deep learning. I know almost everyone in this channel is an expert in machine learning, but the first part is for people who are new to deep learning and healthcare. Okay, deep learning in healthcare is a new and rapidly exploding area. And here are some of the few examples, right? A couple of months ago, DeepMind solved a 50-year-old grand challenge in biology using an algorithm called AlphaFold. Google and Verily uses AI to screen patients in diabetic retinopathy. Hospital uses AI systems to help patients with sepsis, and also like Apple and Google heavily invest on AI analysis and healthcare data. Recently, Microsoft invested 40 million on healthcare initiative, and UK uses AI to predict COVID-19 vaccines. Right? These news tells us that AI is heavily used in healthcare industry. I used Google Trends to plot this interesting graph, which is like over like the last 10 years. As you can see, over the last 4 years, there is a tremendous increase in AI in healthcare. In the later part of the presentation, we will see what's the reason behind this tremendous increase. Before getting into the part where why deep learning is really good for healthcare, let's have like a quick review of like neural networks, right? Uh, Early neural networks, in my opinion, like almost all the basic deep learnings are built during 1990s, like CNN, LSTM, and backpropagation algorithms. Jan LeCun introduced the famous CNN architecture that is widely used in almost all of the computer vision algorithms. LSTMs and recurrent networks are also invented during this time period, which drives the NLP research for several decades after its invention. Also, we must mention there were like a couple of AI winters during like 1990s to 2000s due to like less computational power. And now the modern era, right? Deep learning. During 2012, Jeff Hinton and Alex Kruchowski team at University of Toronto used a variation of Jan LeCun's CNN architecture using backpropagation and called that like AlexNet, and participated in ImageNet Visual Recognition Challenge. As you can see in the graph, there was like a tremendous improvement in the loss from 2011 to 2012, almost like a 9.4% improvement. This was like a eureka moment for deep learning. In my opinion, the three main ingredients of deep learning are like the first one is algorithm. Like we discovered new and innovative architectures and algorithms that speeds up like the training process. And we started using very deep networks for highly accurate predictions. And the second one is like compute. NVIDIA is like releasing new GPU hardware every year with very high computational power. And there are also like very great improvements in like parallel computing, distributed computing, and cloud computing. The third one is data. Because of the internet, we have like a massive amount of data, right? Data is like the major player for deep learning during like the last decade. Also, as you can see in the graph, each year there are like further improvements in like neural architectures that improve the results. During this time, the deep learning community came up with like several backbone algorithms, like architectures like ResNet, DenseNet, EfficientNet, that can be used in almost all the computer vision tasks. Also, by using these algorithms, we further gained very high accuracies in like image segmentation, semantic segmentation, and panoptic segmentation, like the one shown in the picture. Not only that, in 2018, like there was another breakthrough moment in NLP community called transformers and BERT. BERT is like an unsupervised algorithm which gave very high accuracies in like various data sets like question and answer pair, data set, text classifications, topic modeling, etc. Now BERT and transformers became like the standard algorithms in almost all the NLP tasks. Before it was used to be encoder decoder architecture. Now let's get into like why deep learning is like really promising avenue for healthcare, right? The rise of the medical data is the most important thing apart from deep learning algorithms. Nowadays we have like CT scans, X-rays, and MRIs. We can use the above mentioned like deep learning vision based algorithms to predict like pneumonia or like lung cancer using this data. Apart from medical imaging data, we have different forms of data like patient measurements like oxygen level, blood pressures, clinical notes by doctors and physicians, and lab results. Electronic health records were invented in like 1960s, kind of became popular in like 1980s, and in 2000s due to like the High Tech Act, like the US hospitals adopted like 51% of electronic healthcare record data. And in 2017, almost like 98% of the hospitals started using electronic health records. That's one of the major reasons why deep learning revolution in healthcare is happening right now. Not only electronic health records, we have seen like tremendous increase in genomics data as well. Like in 1950, we kind of like discovered the helix structure of DNA, and in 1977 we discovered like the full genome of a virus, and in 2003 only we sequenced like a full human genome. But by the end of like 2018, we have like hundred thousands of genomes. Like the point is, we have like millions of data, as millions of genomic data as well, right? And like why and let's talk about like some applications of deep learning in healthcare. The first one that comes to mind is like explainability and interpretability. Deep learning was considered as like a black box before the invention of like lime, SHAP, gradcam algorithms. But yeah, but don't get me wrong, but we still don't know the theory behind deep learning algorithms and why stochastic gradient descent works. But these explainability tools like SHAP help us to figure out why deep learning algorithms made certain predictions. For example, using explainable AI, we can see why deep learning algorithms predict breast cancer, etc., etc. You can refer these papers for like more details. And like the second application that comes to mind is drug discovery and interaction prediction. So we have like a lot of protein structures, right? And we can use unsupervised algorithms like autoencoders to get like the latent representation of the proteins, and we can use that latent representation to figure out like new drugs and how drugs interact with each other. This is like one of the major area of like deep learnings in healthcare. And the other one is like clinical event prediction. In hospitals, we only have like a certain number of ICU rooms available, right? So if we can able to predict how long a patient will stay in an ICU according to like medical conditions, we can allocate the available number of ICUs to other patients, and we can tell when we can like make new beds for like new patients, right? So it's very helpful for both patients and the hospitals. And I think I imagine these techniques were like widely used during COVID as well. And not only that, like recently, like a lot of applications, like a lot of deep learnings has been used in like COVID-19. So for example, we used CT scans of COVID-19 affected patients to figure out like whether a person has COVID or not, right? Also, like we used deep learning to predict COVID-19's RNA structure. And Yan et al. Paper tried to predict whether a patient will survive or not due to COVID based on like medical conditions, right? And in Vector Institute, we developed like a deep learning based application for contact tracing. So like there are like many applications of deep learning in healthcare. But the question is, why aren't these deep learning systems widely deployed in hospitals yet, right? I think like based on what we have seen until now, the promise of deep learning in healthcare is really great, but there are many open challenges in like production and deployment settings. I think like deep learning has a proof of concept to production gap problem. What I mean by that is like I think like the ML code and like the real-time deployment here. As you can see in this picture, ML code is like a very small portion of like a real-time system. The real-time system includes parts like data collection, feature extraction, machine resource management, serving infrastructures, monitoring, etc. So we need to think about all these before deploying our model. In my opinion, this is like the main gap in deep learning today. Like as well as like these are some of like the practical limitations to deep learning deployment according to Andrew Yang when he gave a speech at like Europe's 2020. So what are those are like the first one is like small data, like not having enough data, and generalization and robustness, and the third one is safety and regulations. Let's talk about like the small data. Right, so deep learning works well when the data has like an equal distribution among classes. Like for example, in the left side, we have like an imaginary data set, right? Like we have like thousands of classes, and each class has like thousands of examples. But deep learning does not work well when we have like a unbalanced data set, and our like data set has like a class imbalance. For example, the right side we have like hernia has like less than maybe 500 images, and effusion has like 12,000 images. So obviously, deep learning algorithms works well on effusion disease and not like hernia, but that's not what we want, right? Also, like there is another problem called human versus deep learning, like top 10 conditions problem, right? What do I mean by that is, if you give an image and a medical history, a radiologist can diagnose like any of the large number of conditions, but today's deep learning might be able to diagnose only like the top handful, right? So like, for example, like what's easy for a deep learning algorithm, like diagnose pneumonia from approximately 10,000 images is like really easy, and we can do it like in minutes. But what's hard for deep learning is diagnose a rare condition from like 10 images of a medical textbook and given like two paragraphs of text explaining that condition. But human radiologists can do this well. So how can we able to mitigate like the small data problem? So there are like a couple of ways to do that. The first one is data argumentation. Um, Medical data argumentation is different than ImageNet data argumentation. Uh, we need to think and create healthcare-oriented automated pipelines for data argumentation. In the paper I mentioned here, like they take a picture of X-ray in their mobile phone, and it does some kind of like data argumentation relevant to medical X-rays, which were implemented by talking with radiologists. And by doing this data argumentation, we can get more data points, and we use that data points to like train our algorithms. Refer this GX photo paper, it's from Stanford. I mean, for more details. The second one is data synthesis. Also, to get like more data, we can use synthetic data, right? For histopathology images, like it's rare to get all those data sets. It's usually we only have like thousands of like maybe like 500 images, right? But to get like more histopathology images, like this particular paper uses GANs to synthesis new data. And using this new synthetic data, this paper achieves like state of the art results. And also we can use techniques like random dominizations, etc., to uh, create more synthetic data. The third one is pre-training. So, for example, in this paper, GXBird, they use like pre-trained model to label the output of radiology reports. They use like the bird weights to annotate radiology reports using a rule-based system, and then they fine-tune the model on a sample set of expert radiology annotations to get like higher accuracy. So that's how we can able to like mitigate like the small data problem. And the second one we talked about, we want to talk about is robustness and generalization. So what do I mean by that? Uh, a model that works well, according to a published paper, often does not work well in production setting. Like for example, if you take a well-defined data set and train a neural network on it, it will give you like a very high accuracy, like sometimes more than like a human radiologist as well, right? So if you take the same model and use it on like a real-world hospital setting, the model doesn't perform well. The model does not generalize well. Actually, this is like true for uh, many machine learning across many different industries. I think we need to work as a community to solve this problem and focus more on like generalization and robustness techniques, and then like we can use more like privacy preserved techniques like differential privacy to secure our data. The other one is safety and regulations. Like patient safety is very important. How can we make sure an algorithm that does not cause harm, right? I think we still need to set clear standards to which we expect a deep learning system to be held, not just only on like test accuracies. Like we need to talk with doctors and engineers and regulatory bodies to create like a standard for medical data. And the second one is we need to have like a clear process to audit an deep learning system to see if it's meeting those standards, right? For example, many machine learning researchers don't feel good about like auditing their model. I would love someone to audit my deep learning model because it is supposed to work as it is expected, right? So it is like I would love if someone can validate my model. So I think we need to include explainability a lot in healthcare because it's important to patients and doctors, and it's very important for deployment as well. I think what we need to do is to adopt software engineering principles to machine learning and deep learning, because deep learning is only like booming for like last 10 years, but software engineering has tools and experience that has almost like 50 years of experience. So I think it's wise to use software engineering principles here in deep learning. And statistics says that almost like 70% of the deep learning projects fail to reach like the production stage. The most common reason is because we are not following standard procedures. There are like several standard procedures out there, but CRISP DM is one of like many, and it's widely used in like all industries. There are like 6 stages here. So the first, we need to have like a better business understanding, like what's the business objective, like data mining goals and project plans, right? Then we need to like understand what the data is like. There are like several stages like data collection, exploring the data, verify the quality of the data. Then we need to prepare the data for our project. Data cleaning is like the major part of like every project, and data scientists spends like almost 70% of the time on data cleaning and formatting data and which data we want to use. Then only we will like jump into modeling, right? So select like which algorithm we want to implement, generate test designs, build models, assess models. And the fifth stage is going to be like evaluation. Like evaluation is like a very important aspect of the project. We need to identify what are the business metrics and algorithmic metrics that we care about and for this project, and evaluate results on that. Then only finally we will think about deployment, like using tools like MLflow, Kubeflow, or Algorithmia that are used to deploy deep learning models. And we need to also have monitoring and maintenance processes. And also we need to like document these steps so that the other person in the team that can easily come and join the team and start working on it. So what I'm trying to say in this talk is we need to think deep learning as like a systemic engineering discipline rather than a science, right? For example, thousands of years ago, if we ask human to like how to build a bridge, they will say like put one log behind another and and build a bridge, right? But now we have a separate big engineering discipline called civil engineering, right? So the bridges we build now stands for like thousands of years. Unfortunately, for deep learning, we are still in like the stone old age, but we can utilize these tools and best practices from software engineering discipline, and we can use those tools and build more tools that makes deep learning systemic engineering discipline. So some of the directions for like full cycle deep learning are we need to focus on like data editing and data versioning tools. Like I mean, most of us will use our time in like training and testing, like dividing the data set into get different parts, and we will use like we have to use different tools like GitHub, GitLab, and DVCs to have like a versioning of models. And we need to focus a lot on performance auditing, safety monitoring, and regulatory compliance. And of course, we need to invest a lot of time on MLOps for healthcare. So like finally, this is the picture that I want to share with everyone. Like as you can see, like there are like different stages and like different tools for each stage. For example, in data stage, we need to think about storage, database, and like processing, and which tools to use, whether to use like SQL or MongoDB or S3, etc. Right? For development stage, we have like different software engineering tools uh, like PyTorch, TensorFlow, GitHub, and Jupyter notebooks. And in training and evaluation stage, we have like different tools like resource management and experiment management and hyperparameter tunings. And in like deployment stage, we have like testing tools and hardware tools, right? And also companies like Amazon, Google, and Microsoft offers all-in-one technologies like AWS, Azure, and Google Cloud Computing that has like end-to-end infrastructure from data to deployment stage. I know it's really difficult to choose which tools to use, but it actually depends on like the business case and the budget we have. As a community, we don't have like a standard end-to-end infrastructure yet, but it would be way better if we use these tools that makes deep learning for production easier, especially for healthcare. I think this is like the most important slide of the presentation. Like we have like different tools, and we can use all these tools instead of like working on just Jupyter Notebook. If we use all these tools, and these tools are from like software engineering discipline, and they have been using these tools for like 50 years. And these are some of the, here we see some of the new tools for deep learning, but if we use these tools, it makes our life so much easier for production, especially for healthcare. Um, Thanks for the attention, and I think that's the my presentation. I'm happy to have any questions.
Yeah. Thank you for the presentation. It was very nice overview, Karthik.
Yeah.
Thank you very much. Yeah, so we have some questions here
Yep.
on the chat.
Yep.
So I will go through them, and then I also wrote down some couple of questions. So the
Yeah,
first
for sure.
question is, you mentioned that one of the problem is unbalanced data sets.
Yep.
And here the question is, isn't the issue similar to other like machine learning techniques or even statistics methods? Not only like in subject of deep learning, but in general machine learning, and in generally like not only in healthcare but everywhere else. But
Yeah.
how is it
Go ahead.
different here? I guess the question is here: how is it different from other areas and other machine learning techniques?
Yeah, obviously it's like the unbalanced data set is really a problem for all of the machine learning, but it's especially very dangerous for deep learning because uh, deep learning, I mean, in statistical thing, we have like formulas and like different statistics to validate our response. But in deep learning, it is solely based on like like the objective function. So it is basically trained to reduce like the minimize like the objective function based on like root mean square or something like that. So if we have like an unbalanced data set in deep learning, it's really dangerous.
Mm-hmm.
That's the difference.
Okay, yeah, and I also think like, because my first interpretation besides this technical explanation would be also the
Yeah,
cause of false negative, false positive, right?
for
Because
sure. Yeah.
false predictions they directly impact or can even threaten human lives.
Yeah, that's true. That's true.
So is there like, how would you tackle this problem? Like if you could like design a policy or
Yeah, like there are like different tools for like balancing the data set. We can like upsample or downsample the data sets, or we can even like use data labeling tools like Snorkel. Like you can use semi-supervised approach. You can use the tool like that I mentioned, Snorkel, to like like write some functions to label those data automatically, and that's how we can are able to like balance the data set and then train the algorithm on it. That there are like several research going on, but these are like the standard things that people use nowadays.
nice, thank you.
Yeah.
Other question would be, you mentioned noisy label problems.
Yep.
And so the question is, like, how would you solve it? Because the person is mentioning that there are some inter, and intra doctor label inconsistencies.
Oh, sorry. What?
Uh,
Intra?
Inter and intra doctor doctors label inconsistency. So which I, for example, mean a doctor labels.
Oh, okay. Yeah. See, that's a very interesting question. So different doctors have different opinions, right? So that's why we need to like where is that? Yeah, that's why we need to have like clear standards and clear processes for like like we need to have not only because like deep learning or machine learning generally works on like based on like the test accuracy, right? We need to have well defined and well cleared goals and rules, like which is good and which is not good, and we need to have all these especially for healthcare, so that we can avoid these kind of like problems. So that's what we need to do.
Yeah, that sounds fair.
Yeah.
And so the last question, and right now I'm encouraging anyone who is curious to ask Karthik any question to write it in the chat. But the last question would be rather technical
Yeah.
because you mentioned augmentation of medical images with GANs.
Oh,
So,
yeah.
and here is the problem that you actually need in first place a lot of data, right, to train a GAN.
Yeah. So, I mean, for in this paper, what they did is like they used a data augmentation like this one,
Mhm.
and for especially for like histopathology images, and then they synthesized more data with very less uh, original data. So I mean they showed these results to like actual doctors, and they can't able to like identify which is real, which is fake. So these algorithms that produced the synthetic data that are like really good. So that's why this paper used that data set, and it achieved like a state of the art results for especially for these kind of like histopathology images.
Mhm.
Yep.
And my question would be also
Yeah.
you mentioned that one of the hurdle like maybe a proof of concept
Hmm.
again because it's healthcare and human lives.
Yeah.
So do we see like compared to like machine learning solution in business, do we see like more cautious approach in healthcare to like deliver these proof of concepts? Like does it take usually longer to really do like machine learning practitioners in healthcare really try to prove it like more cautiously under a lot of regulations?
Yeah, that's true because I was working with like, I mean, I'm working with like University Health Network, where like at first when we talk with like doctors, and they would say like, why would I need to like trust a deep learning algorithm? It's just some random numbers, right? That's what people at first starts to say. But when we kind of like use interpretability and other like techniques like SHAP and stuff, and we said like, based on uh, based on based on these kind of like values, and we try to show to the doctors like, because of this only we try to like made this decision. And we are not saying that it's going to like be 100% accurate, but we wanted to show that these are like some of the parts that you can take a look at, and try to figure out whether these algorithm working good or not. So after that, these doctors are like really encouraging us to like show different results. And I mean, they wanted to like involve more, and then I mean, they helped a lot, and then we got those input, and we tried to include that in our algorithm, and that's how it got better and better. So that's what I think, that's what we need to do, because as a machine learning engineers, we only focus on like, reducing like the accuracy, like reducing the loss or increasing the accuracy. But when it comes to like healthcare, you need to focus on like different things, even like a slight dot in like some images is going to be shown different. Like for example, if you have some somehow you made like a small black dot in like a lung, like in a in lung x-ray, and it's going to be like look like so different. So we need to talk with doctors and different regulators to figure out like a standard thing, and we if we implement that, people are encouraging, and people are helpful for that as well.
Sounds good. So yeah, so you mentioned that healthcare regulators. So
Yeah.
imagine yourself in the shoes of healthcare regulator right now, and
Yeah.
like there are like a lot of like hurdles, like why
Yeah.
we see more and more like machine learning and deep learning solution in healthcare. So if you put in the shoes of a health policymaker, like remove one of the hurdles, what would that be?
uh like like the first thing that what we did while we working with University Health Network was like, we actually made like people to sit together, and then like, like trying to like see, I mean, each person has like, as a machine learning researcher, you will focus on like reducing loss, but as like a doctor, you focus on like which part to focus on, which is like which gives like more values, or what are like the different parts of like the x-rays are really important, right? So we need to like sit together and like talk and figure out what are like the different ways that we can able to use machine learning as like a helping tool, not like as like a, I mean, the major misconception is people think like we are trying to like replace the doctors with like algorithms, but that's not the case. We are trying to help the doctors, and we need to like talk together and then like figure out ways to improve the algorithms. That's like the first step, because we are still in like the early age, like early stage for healthcare. So we need to involve a lot of peoples and maybe like lawyers and everyone, right? So we need to involve everyone to figure out like a standard regulatory process, so that we can audit our systems, and we can expect the deep learning to like work as it expected, not like a black box or something.
Get it. So the last question I see here in the chat, and I don't know whether we can answer it, but is have you seen any project utilizing IoT with deep learning in healthcare?
Uh, yeah. For example, people have been using like what to say, like the Apple Watch or Fitbit,
Mhm.
right? So they are using these data from like your like mobile phone or like Apple Watch or Fitbit, and then they try to like uh, give predictive analytics. So like I mean, for example, like Apple Watch has like like a heart attack like ECG, right? So you can use those data, and like you can figure out like if you walk this much and what's your weather at that particular time, and we can, if you can gather all those data and that's like heartbeat data and stuffs. I think one of my colleague worked on this, but I'm not sure what the paper is and stuff. But there are people working on using IoT devices as well.
Yeah, I just recall that like back in the day, or like sometime a long time ago, I like downloaded this application that it measures the quality of your sleep.
Oh
and
yeah, yeah,
and
of course.
when I had like a bad sleep, I
Uh-huh.
actually I had to stop using this application because I had a bad sleep, and then I look at it and it was there. Or even if I had a kind of good sleep and I saw it, my day was ruined.
Yeah, 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 yeah. That's
Just
true. And there is a huge debate going on, like the privacy, right? So, is it like good to share our health-related data to someone? So, I mean, people are trying to work out different ways right now. So, we are in like a really good time if you want to be involved in deep learning and healthcare, because a lot of things going on, like privacy and like regulations and how to use deep learning and etc. etc. So, it's a good time to be
yeah.
part of deep learning and healthcare.
So yeah, I can like I don't have a lot of experience in that, but like on the side note of resources or allocation and the regulation. I like recently talked to a CEO of one of the largest eye clinics in Europe, and
Mm-hmm.
we were talking about AI because they already use some machine learning solutions, but he specifically mentioned a problem like because of the GDPR and so on.
Yeah,
Like
yeah,
they need to have their own servers, right?
yeah, yeah.
They
That's true.
cannot. They cannot even have it like on the cloud somewhere.
Yeah, yeah, yeah,
So
yeah.
utilizing a GPU or something like that, they would need to buy their own resources, which is like a
That's true.
for a particular clinic, it's not very beneficial, or it's a lot of resources.
Yeah, yeah, yeah. I think like for that, but like for that scenario, like people. I mean, there are techniques like federated training, something like that. So that actually secures our data from. I mean, from not I mean, even if you anonymize the data, people can try to figure out who you are based on like the model. They can query the model and then like try to figure out who you are. But if you use these differential privacies and federated learning, then it is kind of like actually difficult, and it preserves our privacy as well. So
Oh,
people working on that as well. So it hopefully in a couple of years we can use all the data. Maybe, I'm not sure, but yeah.
okay, federated learning, right?
Yeah,
I
federated learning and
heard
differential privacy.
I heard about it first for the first time in my life, so I will definitely go and Google it.
Yeah, of course, yeah.
Okay,
And yeah.
go ahead.
I'm good.
Yeah, okay. So I think it was all, Karthik. So just to briefly summarize what we went through, it was an overview of machine learning, or specifically deep learning in healthcare. Why don't we
Yeah,
see enough of solutions in the deployed or in the healthcare yet? And it's mostly because of regulatory policies, allocation of resources, and again, data is the source of AI or everything. So
yeah,
unbalanced data set, or not very well labeled or mislabeled instances are the cause as well.
yep,
And in the end, we discussed some other fields, and also like this federated learning. We learned something about it. So thank you a lot, and it was
yeah,
great having you here. Good night,
yeah.
everyone.
Thank you so much. Good night.
Thank you. Bye.
Bye. Is done.